Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about the Martian dust storms that just won't quit. Another solstice, here we go again. Rare black hole found eating its dinner, and of course, your listener questions about all things in the universe. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. In today's Blue Shift, I'll be talking about how you are making this show better. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI. For the next half hour, your agent to the stars. I've got an exciting show for you today on Space Radio, where we talk about all the beautiful and wonderful things in the universe. There is a lot of it. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern, usually in Studio A of WCBE Radio Columbus, somewhere different today. So call 888-581-0708. You can also follow along with the other space cadets on Twitch and YouTube. Go to spaceradioshow.com for the links. And hello, a big shout out to the listeners watching this stream live from Austin, Texas, London, UK, Cape Town, South Africa, Athens, Greece, and Kharkiv, Ukraine. Interesting. I'll get to that one later. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I start taking calls today, I wanted to share some cool space and astronomy news, and there's a lot of good stuff going on. Number one, I'm recording this on Thursday, June 21st, which is the solstice, the summer solstice, the longest day or close to the longest day in the northern hemisphere. If you live in the southern hemisphere, then you're SOL. It is the shortest day for you. And if you live south of the Antarctic Circle, you are pretty much miserable, but that's a year-round kind of thing. But today is especially miserable because you get no daylight at all. The sun will not rise. And of course, if you're above the Arctic Circle in the north, you get 24 hours of sweet, sweet sunshine, which you need because it's a frozen wasteland up there. But here in the mid-latitudes in the northern hemisphere, it's nice long days. So if you're planning on going stargazing and taking advantage of the warm weather, you gotta stay up quite a bit because this is the longest day. It needs to be dark for stargaze. Anyway, that's just happy solstice, everyone, or, average to okay solstice. I'm not going to make it be happy. It's just an astronomical fact that we can take note of. But things aren't looking so great on Mars. This dust storm that bloomed about a week and a half ago is now classified as a worldwide, a Mars-wide event. It is a global sandstorm. And when I talk about Martian sand, Martian dust, I get the feeling, have you ever been on a beach and a strong wind comes up and you can feel the little bits of sand digging into your flesh and it sting, like you're being sandblasted? It's absolutely nothing like that. First off, the atmosphere of Mars is just 1% the atmosphere of Earth. So even gale force winds, hurricane force winds, you're not going to feel hardly anything at all because there's just not a lot of molecules to slam up against you in the air, so you actually get the sensation of wind. But these winds are still capable of picking up Martian dust, which is way tinier than anything you might feel on the beach or pretty much anywhere on Earth. The next time you have some baby powder around, and feel free to buy some at the store if you need to, puff that up into the air. That's about what we're talking about when it comes to Martian dust. Mars has been blowing dust for at least 3 billion years, and it's really, really good at it. And it's had a long time to grind that dust into something like talcum powder. And that's, even though the atmospheric pressure is so low, there's so little air, it can still pick up these tiny fine grains, distribute them through the atmosphere. And who knows how long this storm is going to last. It could be just a couple more weeks, but it's looking like a few months. And even the next round of Mars missions that are en route to Mars as we speak are getting a little nervous, because by the time they land, that storm may not have passed. And that's the latest and greatest when it comes to space. It's time to talk some questions. Space cadets, hit me up with some questions before I get to the next segment. Thank you, Scott. It is a beautiful room. Yes, Nancy Graziano, calls are accepted. I'm going to talk about that at the end of the episode. We now have the technology to take calls wherever I can find a decent internet connection. But I do need questions. Do all galaxies have black hole at center? Perfect, Gem. I will talk about that, and I'll use that. I'll use the story of the intermediate mass black hole to lead into that. Next segment. The first question comes to us today from the Space Cadets over on YouTube. We've got Jim Becker asking, do all galaxies have a black hole at their center? And this is very, very interesting because it's topical and relevant with the news that's coming out just recently about a rare kind of black hole. So let me answer Jim's question first, and then I'll circle back to the news I may have to go into after the break to finish it all up, because I really want to dig into this, because black holes and galaxies and their toxic, poisonous relationship that has existed for billions of years is something that we need to talk about. We need to address, because if there are toxic relationships in your lives, you just need to get it out into the open. And the toxic relationship I'm talking about here is black holes and galaxies. So every galaxy has a whole bunch of black holes. These are the leftovers of dead stars. But every galaxy has at least one black hole that is very special and very interesting. These are a kind of black hole called supermassive black holes. And as the name suggests, they are somewhat on the large side. They usually tip the scales at well over tens of millions of times the mass of the sun. And I don't know how you personally classify massive versus supermassive, but that's good enough for my book. And so these monsters are known as supermassive black holes, SMBHs, if you're in a hurry. Now, it is thought that basically every single galaxy hosts a supermassive black hole in their centers. This is because there's an evolutionary link between how galaxies grow up. They form dense cores. There's a lot of material. There's a lot of stars. There's a lot of dying stars. There's a lot of small black holes. These black holes merge together, group together to become big black holes. These big black holes feed on the surrounding gas. Gobble, 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 gobble. Not like a turkey, but as in eating something. And they gorge themselves on the dense clouds of gas and dust found in the center of every galaxy, and they become large. And there's a rough but pretty decent relationship between the size of a galaxy and the size of its central supermassive black hole. So they appear to be linked evolutionarily. I'm not exactly sure how to pronounce that word right now, but we're just going to roll with it. And so it appears that there's two kinds of black holes in our universe. There's small garden variety stellar mass black holes that aren't all that special. I mean, they're really special and really cool and really interesting, but for this discussion, they're not very special. And then there are these giant black holes that sit in the centers, the supermassive, and there's a big gap between them, where you look out in the universe and you either see, 5, 10, maybe 30 or 50 times the mass of a sun for a normal garden variety black hole. But then you go in the centers and you've skipped the thousands, you've skipped the tens of thousands, you skipped the hundreds of thousands. You're all the way up in the millions, tens of millions, even billions of times more massive than the sun. That's quite a jump. Where are the middle ones? Where are the so-called intermediate mass black holes? And it's kind of hard to pin down. They are definitely rare, which leads us to suspect that nature doesn't form them easily, because if it were a common thing, we wouldn't have to work hard to find them. Instead, we're still in a state where even after decades of observations, the evidence we have for the intermediate mass black holes are circumstantial, a little bit hand wavy. There's other interpretations of the data, but day by day, more links get added in, and we're starting to paint a picture that there really are intermediate mass black holes in the universe. There may even be an intermediate mass black hole orbiting our own supermassive black hole. By the way, the name of our supermassive black hole is Sagittarius A star, for the curious. If you look in the direction of the constellation Sagittarius, you're looking in the direction of the center of the Milky Way galaxy and in the direction of our supermassive black hole. Now, where could we possibly find these intermediate mass black holes, and how does that have to do with the latest news? Well, you're going to have to wait till after the break. Thank you, Jim, from the Space Cadets on the live stream, for that wonderful question. We are going to take a quick break. Don't forget to call 888-581-0708 to join the conversation. You can join all the other wonderful Space Cadets on YouTube and Twitch. Go to spaceradioshow.com for the links. I'm Paul Sutter. This is Space Radio, and this show is brought to you by you. Go to patreon.com/PM Sutter to learn how you can keep supporting the show. All right, so I'm going to finish Jim's question by going to the news, and then Ender G. Wiggin, I don't think that's your real name, talking about career paths for NASA, SpaceX, and Blue Origin. I'd love to talk about that. Oh, and Frank, I'll slip yours in too. Could these supermassive black holes be remnants of the protostars? All right, next segment. Where are my notes? Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. I've got more questions ready to go, but remember, you can join the conversation by calling 888-581-0708 or by following the live streams. Go to spaceradioshow.com for the links. Now, I'm finishing up one question by Jim on YouTube with the Space Cadets, and Frank Tippin asked a similar question. Could the supermassive black holes be remnants of the protostars or pre-stars? We're not exactly sure what seeded these giant black holes, whether it was stars in the very early universe 13 billion years ago, whether it was just dense clouds of gas and dust collapsing in on themselves, whether it was something else. We're not exactly sure how they grow so quickly, so big so quickly. Is it merging? Is it accreting gas? Is it more of one than the other? But definitely intermediate mass black holes are a stage of getting to supermassive, because if you start out small and you want to get supermassive, that road passes through Intermediateville. You don't get any other choice. And it appears to be that this is an incredibly rapid process, which is why we don't see a lot of intermediates. But where could we possibly find intermediates? Well, maybe in intermediate galaxies, or maybe globular clusters or stellar clusters. Like smaller groups of things might host smaller black holes that got stunted, that wanted to be supermassive but got stopped because they ran out of food, and so they couldn't get as fat as they wanted to. But this poses a challenge because it's kind of hard to see small dwarf galaxies, globular clusters, and so on, because they're small and they're dim, and in astronomy it's hard to see small and dim stuff. So we don't have a lot of data, we don't have a lot of surveys, we don't have a lot of knowledge of these kinds of objects, and then it's even harder to search for black holes in the centers. But we got lucky. There's an announcement in a paper, recent observations of an X-ray flare coming from a star cluster, and all they saw was X-rays. All they saw was a flash of X-ray. It flared up, and then it took about a decade to dwindle down. And then you ask, I wonder what could make flares like that? Well, we know that when stuff falls into a black hole, it heats up, it gives off a lot of light as it's compressing into that tiny, tiny volume. And that can emit X-rays, and then eventually the X-rays go away as the stuff is actually consumed. And you can get flares like this when a black hole eats a companion, when an entire star falls into a black hole, gets torn to shreds, violent outbursts of radiation, then consumed by that event horizon, you get a flare that slowly dwindles down. So we've seen these. We've seen these around supermassive black holes. We get big, giant X-ray flares. We've seen these around stellar mass black holes where you get itsy-bitsy little X-ray flares. And what we saw in this case was a medium, a mama bear kind of X-ray flare. It was just in the middle. And the best way to model it is with the existence of an intermediate mass black hole of around 10,000 times the mass of the sun. Now, is this conclusive evidence? Of course not. But it is a very strong indication, and it adds to a few years worth of hints like this that yes, intermediate mass black holes do exist. They're not an extinct species in our universe, but they are definitely endangered. Now, totally switching gears, I had another fun question coming to me from a space cadet over on Twitch, Ender G. Wiggin. I'm pretty sure that's not your real name, but that's okay. Asking about careers. You know, if someone wants to go into NASA and SpaceX and Blue Origins, you know, what are the different paths what could take? Schooling, internships, all that kind of stuff. And I would have to say, if I had to rank questions in terms of popularity that I get, number one is black holes, of course, all the time. Number two is, hey, can you read over my crazy theory of the universe? And the answer is always no. And then number three is, hey, I'm interested in all this spacey kind of stuff, whether as a physicist or an astronomer or, you know, rocket engineer. What do I do? What do I do? Well, the beautiful thing about any career in science or engineering is you don't necessarily have to be skilled in the areas, the disciplines that you think you might be. You might think that you have to be a top flight mathematician right off the bat. No. Mathematics, especially the kind of mathematics you'll use in high level physics or engineering, is something you acquire. It's a skill. No one's born knowing differential calculus or algebraic topology. This is something you learn. The mathematics comes and it's taught to you slowly in stages because, it's kind of hard, so we take our time with it. Instead, you take what you are passionate about, what you do enjoy doing. Do you enjoy computer programming? Do you enjoy graphics design? Do you enjoy, accounting and numbers? It doesn't matter. And if you take that skill that you have, and then this love of rocketry or astronomy or space or physics, you can go into that field and take your skills with you, because you know what? Even SpaceX needs graphic designers. I'm pretty sure an engineer didn't design their logo because it looks way better than if an engineer had designed their logo. So you can marry your skills with your passion, or marry your skills with something you're fascinated by. In schools and institutions, it's the same story. I get a lot of questions from high schoolers and even middle schoolers, like, what do I do? Where do I need to go to grad school? I need to go to postdoc. No. That's like decades out. That's decades out. First step, try to get into a good school that matches what you want to do, has a good program that's relevant to you, offers you the right set of challenges that you'll need to succeed, that fits your lifestyle, all that good kind of stuff. First, focus on getting into that school. Then once you're in that school, focus on doing well in the school. Focus on doing well in your classes, absorbing the information. Don't worry about knowledge that you're going to need 10 years from now. Don't worry about the differential calculus now. You'll learn differential and you'll apply differential calculus when the time makes sense. Believe it or not, we thought about all this and we designed the curriculum and the career paths to take this into account. So take a deep breath and just focus on the next step. If you want to work at SpaceX, then go to a good engineering school and apply to internships at SpaceX. And it's as simple as that. And you'll face those challenges one at a time. Thank you so much to all the space cadets for all the questions that I was able to answer on this episode, and the ones I couldn't. You can join the conversation too. Call 888-501-0708 or by joining the live streams. That's spaceradioshow.com for the link. So unfortunately, we're almost out of time today on Space Radio. But before we go, it's time for the Blue Shift. And Ender, yeah, that's why I was making that. That's not your real name. I know sci-fi, but don't tell me what happened in The Expanse yet, because I haven't watched it yet. You're welcome, Jim. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. Now, you may have noticed that I sound perhaps a tiny bit different. That is because I'm traveling this week. I'm not in Columbus, Ohio. I'm not in WCBE. I'm not in Studio A. I am in glorious and gorgeous Kharkiv, Ukraine, mostly eat as many pierogies as I can, which I have succeeded, but also because there's an astronomy conference going on here that I wanted to attend. And a while ago, so I have a somewhat crazy travel schedule, and we used to have to take breaks where either I would record 2 shows and just do an interview and we'd play back the interview, or just do a rerun while I was gone. I'm happy to announce that those days are over. Why? Because of your Patreon contributions, we were able to buy the gear, some very cool hardware that's very portable, some very cool software that is digital and so very portable as well, to have all the right combinations of stuff so that I can record the show and host the show and live stream and field questions from the Space Cadets and take calls anywhere in the world with decent Wi-Fi. That's it. But there's a lot of places nowadays that have decent Wi-Fi. So I'm actually recording this in my hotel room using the hotel Wi-Fi. We are streaming online. The Space Cadets are wondering why it doesn't look like a studio behind me and debating if it is in fact a green screen. It is not. It is my hotel room. And even though we didn't get any calls today, we can support calls. So you can call in every week and I can answer it, and the live streamers will catch it. And of course, Greg will catch it for editing. So there is no Greg right now. I'm handling all the calls myself. And Greg, if you're listening, which you ought to be because you're supposed to edit this show, I miss you. And I still need you, even though we have all this fancy, expensive hardware and software. We still need our Greg to polish up the show. And it's way, way easier when he's behind the scenes running everything. So thank you, Greg, even though you're not here. And thank you to all the generous contributors who are not only just keeping the lights on and the radio waves blasting for this show, but enabling us to buy more gear to make the show even better. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. That's PMSUTT. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. That is every Thursday. Call 888-581-0708 to join me on the air. You can also follow with the Space Cadets on YouTube and Twitch. Go to spaceradioshow.com for the links. You can also follow me on all social media platforms. My name is Paul Matt Sutter. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. We did it. Stop. Back on just in case. Esther B, will I take a summer break? No. This show goes all year long. And I know it wasn't the best Wi-Fi. I had to drop the quality, and I hope it didn't drop too many frames and buffer for you too much. Audio's back. Yeah, sorry. It's because I'm using a program that records, like splits the audio and records, and then also pipes it out to OBS so I can stream to you guys. And I turned that off because I was done recording, but I forgot. You can't hear me now. But I did say, Necroticus, you should be jealous of all the pierogi, or Veroniki, as they call them here. I have eaten them every single day. Okay, some buffering, some offline periods, but not bad. Like not bad. And this really was a test. This is our first time trying to stream the show, record the show, host call-ins, the whole deal, the entire production pipeline that we usually have in the studio, but doing it remotely. And I'd say it was a success. But one last thing before all you space cadets go, I do need a suggestion for a name for the episode. So let me hear it. By the way, this hotel is amazing. This is one of my favorite hotels I've ever stayed in. And who would have known? M. Chuban, cool to see you on Twitch too. Sorry, Escape EP. I just finished the recording. And I'm going to sign off in just a little bit. Goldie Flares and the 3 Black Holes, not bad. Anyone? M. Chuban, feel free to toss something out. But the hotel managers are wondering what the heck is going on with their Wi-Fi. The day I got here, I streamed on Twitch on Skylius' show. This morning, I was Skyping into the Weather Channel. And now I'm doing my own show. Astro B, I'm here for work. There's a conference going on. Yeah, if I had to pick holiday destinations, I don't think I'd normally pick Eastern Ukraine. All right, if there's no better titles, I'm going to go with something along the lines of what Nancy suggested, which means it's time to sign off. I'll see you guys next week, and I'll be back in beautiful Columbus, Ohio. Binging black holes, maybe that. Robin said I'll be back in the studio with our connection next week. So this is about once a month I'll be doing remote. How do I end this thing? There we go. Take it easy, everyone.